All right, hi everybody. This is Kubernetes SIG architecture meeting for Thursday, September 19th. Let me share the agenda. All right, we have two items here. I don't see Patrick on the call. I think, and I don't see Mo either, who just commented on that recently. So I'm just going to push that item. I think that the point of this, I mean, yeah, probably can be brought up with that team, but we've had discussions here in the past of similar things like, are there certain CRDs we want to be built in and therefore automatically loaded with the whenever the API server starts, and how do you deal with it in HA circumstances? But anyway, Patrick's not here, so we will jump to the other topic. Philip.
Hey. So yeah, I would like to discuss this topic we have, and basically we have two approaches. And so I will quickly go through these. First, maybe I can reiterate the issues we are trying to solve. So like the main the main contention point is that we are basically trying to have an alternative to basic disruption in Kubernetes when you have pod disruption budget and eviction. So in a normal model, when you, for example, drain the node, you try to evict each pod exhaustively until they are gone, and this can be blocked by a pod disruption budget. So this is not great in all situations, and we would like to have a more graceful solution. So, for example, one point or one issue is that today there is no graceful disruption of single replica applications. So when you have only one replica, you cannot use a PDB to unless the PDB will completely block the disruption or the eviction, which you cannot drain the node after. And the second point is that there could be some other resources to check when doing the eviction. So so you could, for example, check some other resources. For example, if you have an application that runs across multiple clusters, you can then distribute the disruption accordingly. And so basically, when you do the eviction, only pod disruption budget is consulted. So and so like one solution is the evacuation API cap I have linked there, which basically changes basically we try to do the disruption asynchronously. So instead of having a result right away once we fire the eviction API, we will create an evacuation object, or most likely it should be named eviction request. And this would basically allow different components to interact until the pod is removed gracefully from the node. So one example of such a graceful removal is, for example, when you have a horizontal pod autoscaler configured, it could basically detect this evacuation object and then could autoscale to two replicas and then allow for disruption of the first one. Or for example, if you have a deployment with max search, it could also outscale to another node. So basically, we are trying to either forbid the eviction itself or slow down the eviction. So there can be actually some reconciliation process where, for example, you can either first create a new replica, or you can migrate the data from the first replica to another before allowing the deletion. And also why we try to first design this asynchronously is also to because today there are many components that try to implement this eviction logic, where they are trying to evict a pod and basically in a loop, and see like I'm gonna wait until it succeeds. So, for example, if you fire a kubectl drain or a cluster autoscaler, it will try to evict all the pods from a node, and basically this declarative solution would allow to outsource this logic to a different component. So like when there is no special mechanism, for example, there is no hook to or like an evacuator to actually outscale to another node, we would fall back to the eviction API. So the eviction API would be called as a last resort, but the creator of the evacuation would have a would specify an intent to remove the pod, and it would be fulfilled eventually. And one of the points is that this solution would also allow for observability. So we would have a status and see like what the different entities are trying to remove the pod, and actually synchronize between them. And also one of the positives of having a declarative approach is basically it could allow us to do more things in the future. For example, today there is no synchronization between different kinds of evictions. So you have the different evictions, for example, from taint-based evictions, or like from the kubelet, or from some other sources, and this object would basically allow you to synchronize all kinds of evictions, so they would not race together, and could actually remove the pod in a synchronized way. So yeah, we have discussed this with SIG apps, and there is also another solution which is more lightweight, and this is basically to change the eviction API as it works today. So this would be done through a PDB, and basically we would have a set of endpoints in the PDB, and like when you fire an eviction, we check the PDB for how many healthy replicas there should be, and this would check this would fetch a set of endpoints that basically the eviction request could then check. So this would be the lightweight way and synchronous. So like each eviction request would basically result in one or more other requests which is specified by the user, which would then either halt the eviction or postpone it, or return some status which would be then observed by the person doing the request. So basically we would still have to poll the eviction, but this time we would we would not expect that the eviction completes, even though there is a capacity in the PDB. So basically then we could observe the status. Yeah, and this would allow this use case of postponing the eviction until one replica or one pod is replicated in another node, and then it could be removed. Yeah, so these are the two options. David?
Well, I think a high-level question I guess I would ask is why this isn't SIG node. But another high-level question about or comment about an API surface that adds a reference to another URL. I don't think it's a good idea for us to add a reference to another URL that we are expecting control plane components to follow. I think that sort of asynchronous approach has a potential scale and security problems that are going to be intractable for us to resolve.
Yeah, to the first question, why this is not SIG node. Yeah, we have actually, I've presented it to SIG node, but basically this was initiated in SIG apps because this deals a lot of with the application part and how the applications will actually behave. So for example, we have like a follow-up that could be done by the deployment controller and other controllers that could actually use these APIs to actually like have some clever behavior. For example, as I said, for the deployments, so you could actually would not have to change anything in the cluster as you have today. You would have just the max surge defined, and it would basically allow you to scale out of the node instead of scaling down of the node.
So yeah, I think that the question, just to get back to the kind of meta question of why are we talking about it here? Was there some like to just come a kind of community process comments like we don't want SIG Arch to be like an escalation point. Like if there's a disagreement in the SIG, but this is within the SIG scope, like the SIG should make the decision. We don't want to. That's not really the role of this group. But if I think there is one architectural question here, which is like, do we do this server side or client side? Do we do this declarative or kind of imperative? Like, it sounds like, if I understand correctly, it sounds like the second solution is we've got a bunch of endpoints and the client's then responsible for following those or something. And that I'm with David there. That I have a lot of hesitation about that kind of a arbitrary endpoint that we're going to follow. But I don't know the context of the rest of the discussion. I definitely I followed some of the links, but I didn't watch the video. So architecturally, the first solution you described with a declarative model where we put the intent in the API server, and then we have controllers that can interact on that object to come to some eventual conclusion to evict or not, is certainly in line with our architectural principles. I guess that's so from that point of view, that makes a lot of sense to me. But I don't want to. It's not up to us here how it gets implemented, I guess is my point. Yeah, Macha.
I'll try to provide some background from the SIGAP's point of view. We had a thorough discussion, a couple of meetings, the past meeting and previously a couple of times. The majority of this, yes, as you probably noticed, we are somewhere in between. There are pros and cons between both solutions. I think based on the discussion that we had on Monday, the one point that we were considering is expanding the current eviction API with two elements. One, a little bit more detailed information about why the current eviction was rejected for whatever reason, so that we can provide, I don't know, some in-depth information. And two, which I see David minus one a minute ago, about providing an extender. And the reason why we were considering the extender, because that would somewhat mimic the behavior that a lot of users currently do by providing admission hooks on the eviction API. And lastly, the major obstacle that we were seeing with introducing the entire eviction API was basically we already have this many users who are relying on the current eviction API or build their solutions around the the existing eviction API, that introducing entirely new mechanism, which is very well thought out, but it's also at the same time very complicated, would be a major barrier for a lot of the users to actually implement. That's why we were leaning towards improving the mechanisms that we currently have inside of the eviction API through, like I mentioned, the ability to have a little bit more detailed information why a particular request was rejected from eviction, and maybe through the extenders. So I'd be curious why it's okay that we have those extenders in the scheduler. And it's a problematic, it would be problematic in the eviction API, where I'm perceiving the scheduler to be on the critical path, whereas the eviction is less so critical in the control plane working. That was a question to David on his -1.
Yeah, so the issue with a hook is not just the time it takes to run that hook, right? When you have a hook, many other issues come up. Among them, how do you authenticate to the thing that you're hooking into? How many different things have that authentication power? How do you access a network route to get there? Because you can have disjoint sets of pods that can't all reach each other, as a for instance, right? Like that's how do you establish trust? How do you wire things like a connectivity server? And so those questions all arise when you try to invert that model, as opposed to using some sort of a status model on a particular object, right? And that is in addition to, is that other endpoint slow? So there are significant risks to building an API in that direction that I can't stop CRDs from doing, but I would think we should discourage inside of our platform as a whole, particularly ones that will be under general user control, right? So we do have some synchronous hooks, and you can point to them, right? We have authentication hooks. Those are under the control of the person who is configuring the command line arguments for the QAPI server. Tightly controlled, and it handles those cases. You have conversion webhooks. Those are under the control of a cluster admin, and when we add those, we provide capabilities to the person who configures that command line to say, run these through a connectivity server. I don't think we have an example today that places the power to have a QAPI server or controller or other agent make an HTTP request. So a control plane component make an HTTP request. I don't think we allow regular namespace level users to do that. And if I understand it correctly, this would be the first example where we would do that. And I don't think that's a good idea.
Yeah, thank you. I guess that I was not fully thinking through the security problems that might arise from that. But yeah, that roughly explains at least the one question that I had with regards to that.
So on your other comment, much of the idea that we have users that already use the existing APIs, there's no suggestion here to eliminate the existing APIs, is there? This is another layer on top that we would have to build, and yeah, it's a lot of work, and one can ask the question of whether the effort is worth the results, but I can't answer that for anybody. So as far as the questions, I think that's the domain of this group. Like architecturally, that seems reasonable to me. The suggestion, it seemed to go with our principles. As far as whether it's worth doing or not, that's up to the SIGs involved. Yeah, Sergey.
Yeah, I think that's exactly what we tried to discuss on SIG. If we have so many different ways how we evict, and we introduce one more way to evict, will be just confusing more for customers, or confusing less. And like one example I have is like in GKey, we have this notification about maintenance that will be coming like in 12 hours. So like you may want to, I mean, we have a controller that will put some labels, and like we'll have some like, I mean, it's a mess of controllers and notifications back and forth. So it's a custom solution. Ideally, we want to make it somehow declarative and built in into Kubernetes, but it may not be what everybody else wants, because in our case, for this specific notification, for the specific clusters, we want to pods to run as long as possible. So we will calculate graceful termination period for every pod, and like only start deleting them when time is calm. In other cases, one may want to do it as soon as possible, so it will be quite opposite. So once you have this notification about upcoming maintenance, you want to try to schedule everything, all the replacement as soon as possible, and terminate as soon as possible. So it's quite different scenarios all the time, and like it's all can be implemented as a set of handlers and set of controllers on top. So we really need to boil this down to something useful for everybody, some like core primitives, and then decide how we can build on top of those primitives.
So if I'm not mistaken, didn't this have in SIG node as a part of the node maintenance cap? And if I'm reading this one right, this one was split off from the other one. The other issue I think that came up was just like there was no guarantee that this was always going to be used. And it seemed like there was a desire that for it to be useful, it kind of always had to be used. Am I misunderstanding that, or remembering the situation there? Like, I don't know, Flip, if you could give some context on that.
Yeah, sure. So yeah, this was split off from the node maintenance cap, but I think it's useful as a standalone project. I think like there are actually not so many places that use the eviction API. So like if you like the handful of, or not, like there is a like maybe low tens of the node drainers. Like if we could, for example, if you could just replace this API with the eviction API in the cluster autoscaler, that would be already a huge bump. And you could also replace the eviction that's done by kubectl. And basically, we don't we do not have a eviction used as a low or as a basic API. For example, kubectl does not support eviction. You have to either do a raw endpoint, or you use a plugin. So there are not so many users actually using it, I think. And like the handful of places that this could be used for, it would be a benefit. Yeah, I had one other thing.
The only other thing I think I recall on the node maintenance side, which I don't know if applies to this or not, was I think there was concerns on the node maintenance side on like a privilege escalation mitigation or concern that could happen around what nodes could be put under maintenance, and if certain labels had special meanings and that type of thing. I don't know if, I guess, pertinent to the SIG in the architecture section, like if it's worthwhile talking through any like potential privilege escalation angles you proactively saw with this that you mitigated, or that you'd be concerned about, or anything around this approach. Nothing comes to mind right now, but I know on the node maintenance one there was concerns.
Yeah, so I actually have a section in the cap, and I think there should not be like a big problem with privilege escalation. You basically would have to check on admission if the user has privileges to put deletion when creating the eviction request or the evacuation object. And I think that's what I wanted to react before. I think that's like pretty useful area to explore is to actually see if we could integrate it with other like eviction or basically any like pod termination logic that lives today in Kubernetes. So basically, if we could have all places to react to the evacuation or eviction request, and basically like it could be synchronized through that, like what kind of like bot termination would occur.
So Philip, Derek had a question that wasn't quite sure I heard the answer to, which was if this isn't used by everyone, is it still useful? And my follow up to that would be so like I think your response was, well, there's only a few places we do it, so we could update those places, and that's fine for the things that are part of the project. But how many ecosystem projects are doing things, right? And we can't update all of them. So I guess the follow up to Derek's question would be, if Derek's correct and it's not very useful unless you sort of can guarantee that everybody is using it, do you see a path towards limiting the use of the lower level APIs, or sort of what I would sort of say is out of band, right? Eviction, out of band of your controller. Is there a way? Do you have a path to limiting those things to maintain the usefulness of your solution?
Okay, so yeah, there are a couple of layers to this. So first one is that I think there are not so many places. So I think it could be reasonable to update them. And the second part is that actually we've looked before, like if this could be used, for example, as a separate project as offered as a CRD, and but I think like this like a chicken and egg problem, because if you have people or components in the cluster like wishing to do like a graceful like termination of their application, like when they develop the application, they want this they want because their workload depends on it, they want this to, like this kind of behavior to be present in every cluster. And if they can assure that this is present in every cluster, they are not going to implement it. Or basically, as today, like as Maciej said, like some applications opted to using the validation webhooks, and they basically override the eviction, and then it's basically if there is some mistake, then the draining behavior basically stops because it cannot evict the pods. So yeah, and like I think like if this is well integrated, then you could observe the benefits like pretty fast. For example, if as I said, if you implement this in the deployment controller or in HPA, I actually talked with SIG autoscaling, and they said that they would like this in HPA. So if you just integrate it there, then basically when your application scales down to one replica, and then the node is drained, your application does not get destroyed, but is magically autoscaled to another node, and you did not have to configure anything. You just see your application live again. Like yeah.
Okay, I think I can glean an answer from that. Any other comments on this topic? I mean, have you gotten the feedback you were hoping for, Philip, or or Mach or others who are involved in the discussion earlier? Right. Looks like you got some hands. Tim?
I just wanted to say I haven't actually read this KEP thoroughly, but after this discussion, I have opened it up and I will try to give it a more thorough read through. It's an interesting topic with a lot of challenges, I think. But I'm interested in it, so I'm gonna give it a read a little bit later. Sorry, I don't have more concrete feedback right now. It's long. I tried reading it while we were talking. It didn't work.
Sergey?
With regards to what Tim said, do we have an alternative proposal with API written somewhere? I still see the old cap on the link with the declarative pass.
Oh yeah, I can send it to.
Okay, and I mean,
Is
you
there,
can just
sorry, to follow up on that, Philip, is that a separate KEP or is it like an edit to this KEP?
You're muted, Philip, if you're talking.
Yeah, so sorry, I was pasting. Yeah, so basically this is a separate cap. There are two caps: the node maintenance, which is deferred for now, and the evacuation API, like which I have still not renamed, but people would like to see it called eviction request. So yeah, Sergey.
And second question, a comment I had is whenever you say this can be used later for all sorts of different evacuations, I think expectation here, like I can try to do this like map in my head, like how it works for autoscaler and how it will work with the evacuation API. But it will be really great if you can somehow, like, I mean, at least like write down all the existing behaviors and details, so it will be easier to understand how this will be mapped in future. So if you see in some future of mapping other draining logic with this logic, it will be nice to have this mental model somewhere, because I don't have it all loaded in my head, and like quick refresh will be very useful.
Yeah, so basically, like we have run into this while I was writing it, and for now it was just an afterthought how to synchronize the different determination mechanisms, and it's actually specified as a non-goal in the cap. So like if there is an interest, I could write a section to see like if how we could actually synchronize all different determination mechanisms, if it is even possible. Yeah, I have not dived into this deeper.
Okay. Well, I think we bottomed out on this one. So anything else people want to discuss quickly, or shall we give ourselves 20 minutes today?
Yeah, I just want to say thanks a lot for the discussion, and maybe we can move this further and to have like follow up in other discussions too. Yeah, and yeah, Matthew, what do you think?
I'm still processing what the potential path forward. I believe there's still hesitation around building the brand new solution, mainly due to what Derek was also pointing out around how many people actually adopt the solution. And without broad adoption, this pretty big work will be not that much helpful. And I'm still thinking how we can take different approach into improving the current API rather than jumping into introducing yet another one. But I don't have any concrete in my head yet.
Okay. Well, that sounds like fun discussions in SIG apps and elsewhere. So, all right. Well, thank you, everybody. Have a great couple of weeks, and have fun writing caps and reviewing them.
Thank you.
Bye-bye.
Bye.